Good afternoon, everybody. I hope you've had a good week so far. I hope you're ready for the weekend. Does anybody have any cool plans for this weekend? Cool. Yeah, me neither. I'm planning on completely relaxing all weekend. Sounds like a great weekend plan to me. I do want to warn you guys that today or during our class we will have an active shooter drill, so please be prepared for that. I'll let you guys know when it's coming. But I just ask that you guys take that pretty seriously and just for the moment, for the time being, we'll go over a couple of things in class. We're just going to scrape the surface of a new topic. It's not going to be anything too hard. But with that being said, I ask that you please put your phones up and get your notes out and get ready to take some notes and just hang with me for a little bit while we get through this. Does anybody have any questions before I begin? About any content, last week, this week, anything? All right, we'll dive right in. Today we will be talking about volumes of three-dimensional geometric figures such as cylinders, cones, pyramids, prisms, etc., etc. But mainly just a couple. We'll just scrape the surface of a couple, and I'll give you the formulas for those. We'll solve a couple examples, and then that'll be it. First of all, can anybody tell me the difference between a two-dimensional object and a three-dimensional object? Yeah, that's absolutely correct. Two-dimensionals as if it's on paper, and three-dimensional is like it would be sticking out. So if I were to draw a square, what would that be considered? Yes, sir. Yeah, that would be two-dimensional. Good job. But if I drew a cube, you notice how it almost jumps off of the board towards you and looks like a three-dimensional. It looks like it's coming out of the board and looking right at you. Yeah, that's what we call three-dimensional objects. So those are the difference between the two. You guys know that these don't have volumes, they have areas. So I believe you guys know the difference between the two. The volume is very similar to the area. It's basically just the area of a three-dimensional object though. So let's get started. I will give you the equation for the volume of a general prism starting off. So the volume of a prism is equal to its base times its height. It's pretty simple, guys. It's not too hard, is it? I believe we got that one down. A right circular cylinder is equal, the volume is equal to pi. Now don't let that term scare you, just because it's a weird term. It is a Greek term, just like we studied last week. Don't let that scare you. In this case, it's just used as a constant, and then it's pi times the radius squared times the height. Next, we'll do the pyramid. The volume of a pyramid is equal to 1/3 times the base of the pyramid times the height of the pyramid. A right circular cone, so like an ice cream cone, the volume is equal to 1/3 times this constant of pi again, times the radius squared, times the height. And for a sphere, the volume is equal to 4/3. Now try to remember that because it is different than the 1/3 that we've seen in previous equations. But the 4/3 is again multiplied by pi and multiplied by r squared. Now I'll give you guys just a couple of minutes to write those down and get those memorized, but you will need to memorize these once again. They'll be on your tests numerous times, and I won't be giving them to you on the tests. So please have those memorized, and that'll be for your benefit. And sure enough, you may be able to calculate the volume of anything, maybe in real life. But once you have all these written, does anybody need any more time? Okay, good. Good deal. We'll just do a couple of examples. We'll do one example for each of the shapes, and I may draw them out, and I may just give you some. So I would like to do that. If I can get my rag to hang up here, so I can use it to clean off my board. So we will start off with a prism. Now, can anybody give me the formula for a prism again? Yes, sir? Yeah, it's volume equals the base times the height. So what if I gave you a prism with a base of 3 centimeters and a height of 6 centimeters? Can anybody tell me what they may get for the volume? Yes, ma'am. Yeah, absolutely correct. You would get volume equals 3 centimeters times 6 centimeters, and that would equal 18 centimeters squared. Awesome. Great job. Great job. Now I went ahead and plugged the variables into that equation for you guys. But I asked that in the future, you guys just go ahead and take the initiative to do that, because you do know what the variables stand for. You guys are familiar with that. So we'll move on. If I give you a right circular cylinder, sorry, that's not a great drawing, but I'm trying to hurry through these so we can get to our drill. But if I gave you a cylinder with a diameter of 2 centimeters and a height of 6 centimeters, would anybody be able to give me the equation for this? Yes, it is the volume equals pi r squared h. Now in this situation, do we have an r? What did I give you for this value? Correct, that's the diameter, it's not the radius. As we know, the diameter is double the radius. So all we have to do is take the diameter divided by 2. Radius equals diameter divided by 2. So in this case, we have 2 divided by 2, so the radius would equal, everybody, 1 centimeter. Good job. So our volume of our cylinder is equal to pi times what? 1 squared times 6 centimeters. Sorry, I wrote meters, I meant centimeters. Didn't mean to trick you guys that way. So our volume would equal, let's not worry about this pi because it is an irrational number. It's 3.1415926535897, blah, blah, blah. We all know what pi goes on forever, just about. So we can just leave pi in our answer. We don't have to worry about that. We're not going to use our calculators just yet for this, but in our order of operations, we obviously do our exponent first. So what's 1 squared is equal 1 times 6. So our volume would equal 6 pi centimeters cubed. Now we can move on to our pyramids. So you guys think when the Egyptians were building the Great Pyramids, they were sitting around calculating the volume? I'm not sure either, but maybe they were. So our volume for our pyramid equals 1/3 base times height. Now it looks very similar to our area of a triangle, but it is for volume of a pyramid. So if I gave you a pyramid with a base length of 12 centimeters and a height of 4 centimeters, we would plug it into our equation. Volume equals 1/3, 12, and 4. So in this case, what's 12 times 4? Anybody know that off the top of their head from their multiplication tables? Yes, thank you. It's 48. So we have volume equals 1/3 times 48. Now, most of us won't know what 1/3 of 48 is, so all we have to do is put 1 times 48 over 3. So, volume equals 48 over 3 centimeters cubed. Now, I'm going to give you just a couple of more quick examples because we are running out of time. I'll give you one for our right circular cone and one for our sphere. So we have a cone. And then on this side, we have a sphere. Sorry, they're both not the best of drawings, but can anyone give me the volume of our circular cone? Yes, ma'am. Yes, it is 1/3 pi r squared height. Now, can anybody give me the volume for our sphere? Yes, sir. It is 4/3 pi r squared, and that is it. So if this cone had a radius of 6 centimeters and a height of 4 centimeters, what is our volume? I'll give you all some time to solve these two on your own before I go over them. And in this one, if we have a radius of 6 centimeters, what is our volume? Now, I'll give you just a couple of minutes to solve these out while I solve them with the back turned so you can't see my work. Hopefully in the end we'll have the same answers. Alright, so we'll go over our first one really quick. I simply plugged in 6 for our radius, squared that would give us 36, and I plugged in 4 for our height. So 36 times 4 is 144, close parentheses. And I brought down the constants of 1/3 and pi until we got 144 pi over 3 centimeters cubed. I'm not too worried about you guys simplifying these just yet. This answer is completely acceptable, because we won't have our calculators just now, so that is perfectly fine. Now on this side, I'll go over this one together. We got volume equals 4/3 pi, and I gave you the radius of 6 centimeters squared. Does anybody know what 6 squared is? Yes, ma'am, it is 36. So we bring everything else down. And can anybody tell me possibly what 4 times 36 is? You can even type it in our calculators. That's a tough one. I'll let you do that. Anyone give that to me? Yes, sir. It is 144. So our volume is equal to, if we take our numerators, our numerator would be 4, because this is a term in itself. 4 times pi times 36. So that would be 144 pi over 3. Centimeters cubed, which is weird because that's the same answer as this. I did not mean for that to happen, but as you can see, it did. And I'll let you guys get these down for just a second to finish up our class before we head into our drill. Does anybody have any questions for me in any of these processes? If you don't right now, you feel free to hit me with an email. You can even text me through our Remind app. I'm open at all hours of the day. Sometimes I'm open in the middle of the night. Depends on how I'm sleeping. But I'd be more than happy to help you with your questions and your homework. Well, with that being said, I'll ask all of you to please get ready for our drill, and you can all start huddling in the corner, and I'll turn our lights off and lock our door, and we can make sure we're extremely quiet. Thank you, guys.